Okay, so 8.4, I should unlock my computer first on my screen. There we go. Is logarithmic functions. Basically, we will be solving for variables in the exponent position. Would you think I didn't notice?
Mm-hmm.
Put it away.
Did you say throw it away?
Put it away.
It's a drawing.
Okay. Logarithmic functions. So we're going to come where we can solve an equation like this, or anything of that sort, basically. Okay. So the first thing we come to is the definition of a logarithm with base b. Okay. So it's going to look like this. So it's going to be log base b of y equals x. That's just how I write L's. Yeah. Okay, so log base b of y equals x. Okay, b and y both have to be positive numbers. You can't do negatives in there. B cannot equal 1. Okay, this works if and only if b to the x equals y. Okay. Jack, you were sitting in my geometry class yesterday.
Yeah.
Did you catch what we said about if and only if?
There were a lot of theorems going around.
Yeah, there was. If and only if is a biconditional statement, if you remember that a little bit from geometry. That means this works in both directions. Okay? They might give you this, and you should be able to come up with this. Or they might give you this, and you should be able to come up with this. Okay, so it works both directions. Okay, so we're just going to take a look here at a few examples, and I'll explain to you what you kind of have to ask yourself here. So, example 1, okay, we'll just start rolling through that kind of. Okay, this is logarithmic form. Because of the logarithm. This over here is exponential form. Because of the exponent, right? Okay. So if I gave you log base 2 of 32 equals 5, okay, looking at where your letters are all at, you should be able to give it to me in exponential form. Okay, well, b is my base, right? So it is 2. X is over here by itself, so it is. And y is 32. Does anybody know what 2 to the 5th power is? It's 32. Okay. So you can look here, 2 to the 5th power equals 32. Okay, we'll do a couple more here. I'm not going to do all of these. Anything to the 0 power is 1, just so we have that in mind. What about log base 10 of 10 is 1? This would mean that 10 to the 1st power equals 10. Is that true? Yeah. Okay. Things get a little bit different when you start getting fractions and decimals. Okay, I have log base 10 of 0.1 equals negative 1. Okay, that means that 10 to the negative 1st power equals 0.1. Is that true? Yeah, because it's 10 to the first is actually what? Or 10 to the negative first? We know it as 1/10. Isn't that 0.1? It is. Okay. And then the last one we're going to take a look at is log base 1/2 of 2 equals -1. So I have 1/2 to the negative first. What do you do with this? You flip it so it actually equals 2. And that aligns with what we had. Okay. I'm not going to worry a whole lot about the special logarithm values. Just remember, anything to the 0 power is 1. Anything raised to the first power is just itself, correct? Okay. So let's take a look at example 2. They now want us to evaluate these. Okay. So they give us this logarithm, and I'm going to do a different one than what they have. I have log base 4 of 64. Okay. Now, for now, I'm going to show you a different way to set this up. I know that if in just the general form, I should have log base 4 of 64 equals x, right? So I could set that equal to x if I'd like. Okay. And then when I change this, it's going to be 4 to the x power equals 64. So what you really need to ask yourself is 4 to what power gives me 64? To the third. So what's your answer to log base 4 of 64? 3. Okay, so you're asking yourself, 4 to what power gives me 64? Okay, so let's take a look at another one. I have log base 2 of 0.125. Now obviously that's going to be a little bit harder with that decimal. Okay, so I would ask myself what? 2 to what power equals 0.125? Okay, well I know that it has to be negative. Why? Yeah, because if I want a decimal, that means I actually have a fraction, right? Okay, so I know x has to be negative. Okay, and then I get my 2 on bottom. So then if I square it, I get 1/4, right? Okay, so that would be 0.25. What if I cube it? Then I get 1/8. Is that 0.125? So it's actually to the negative third. So in this case, your answer to this would be -3. And I know these are a little bit confusing. Okay, but that's why we're working. I have log base 1/4 of 256. So what am I asking myself here? 1/4 to what power equals 256, right? Now, if I'm changing a fraction to a whole number, what has to be happening, Jedediah? I got to flip it. So my x has to be negative. Okay, so I know I'm going to have my x negative, but now I have to change that 4 into a 256. So how many times do I multiply it by itself? 4 times? So you get -4. Okay. How would you check that? Yeah, plug it in your calculator. Take 1/4 to the -4th power, and you should get 256. Okay, last one on this example, log base 32 of 2. This one's a little bit challenging. So I'm asking myself 32 to what power equals 2? Now, how do I make a number like that smaller by raising it to an exponent? Did I got to use a square root. Okay? It might be a square root. It might be a cube root. It might be a fourth root. It might be a fifth root. I don't know. But I got to figure out what radical on 32 gives me an answer of 2. Okay, so what's another way you could think of this? Couldn't you go the other way and take 2 to the exponent and try to figure out how long it takes to get 32? 2 squared is 4. 2 cubed is 2 to the fourth is 2 to the fifth is. So what does x equal? It's actually 1/5. I do want the fifth root, but if I raise 32 to the 1/5 power, that's the same as the fifth root, right? So here, it actually equals 1/5. And again, you could check that in your calculator. Questions so far? Again, we'll keep using that stuff, so it's not like we're done practicing there. Okay, your next two things that we have are called your common logarithm and your natural logarithm. Your common log is log base 10. Okay, so it's always going to be log base 10 of some number. Okay. On your calculator, that shows up as just log. And then you would type in your x. So where you see everybody see the log button on your calculator? That's log base 10. Okay, it's the most common one. So they call it the common log base 10. So if you have something that's like log base 7, can you use this on your calculator? No. Okay. Your natural log is actually log base e, which we just talked about in the last lesson, of x. On your calculator, this shows up as ln of x. Okay, so the ln button on your calculator is actually log base e. The ln stands for natural log. It's backwards, but the letters are there. Okay. So those are just two things that you're just going to need to know. In your homework, they're going to give you a few where they're just going to tell you, evaluate this. So basically, we know we're asking ourselves, 10 to what power equals 5, right? It's not always going to be a nice number. You're not always going to be able to figure that out in your head. What is it, Brody? Did you just do it? Yeah. Okay, so the log base 10 of 5 is 0.699, meaning that 10 to the 0.699 power gives me 5. It'd be 699 thousandths. Okay. ln of 0.1. Basically negative 2.3, right? So that means that e to the negative 2.3 power is 0.1. Okay. We doing all right so far? I know this is basically all new, right? Hey, we've never even seen any of this, and I get that. Hey, we'll take plenty of time here to work on these. All right, flip over to page 488. Take a look at goal 2. This is really important for us. Okay, what we're going to be able to do is we're going to be able to switch things around, change things, move things to get them in the form that we want them in to be able to solve. Okay. The first thing you need to understand is that log base b of x and b to the x are inverses of each other. So maybe this one is f of x, maybe this one is g of x. Okay? But log base b of x and b to the x power are inverses of each other. So again, we went back a while, not too long ago, but that means if those are inverses of each other, if I do g of f of x, what should that come out to equal? You guys remember? If the things are inverses of each other, it should be just x, 1x, right? You guys remember doing that? Where you verified that things were inverses, so you did f of g of x and g of f of x, and it came out to equal just x. Okay, so g of f of x is actually going to just be x. So let's plug this in. So I have log base b. Instead of x, I plug in b to the x. And that's just going to equal x. So essentially, and I don't want you to put this marking in your book, maybe make yourself a note. Essentially, log base b of b cancels out. Now there's actually more to it than that, but that's probably the best way to sit here and think about this. That cancels out and your x comes down. And I get x. Okay? Now, should it also work if I did f of g of x? Yeah. So let's do f of g of x. So I have b to the log base b of x, and this should equal x. Again, there's more to it than this, but we don't necessarily need to know that. Those cancel. And what's my answer? X. Okay, so be aware of that. If your bases are the same, they cancel out. Okay, if that base is the same as that base, they cancel. If that base is the same as that base, they cancel. Okay, so with that information, what would 7 to the log base 7 of 9 equal? It would equal 9. Okay. What about, think about this one for a second, 10 to the log of 2. Why is it 2? Right, this doesn't say log base 10, but that's our common logarithm. So if they don't write anything, we assume it is log base 10. Kind of like your square root. Do you ever put the 2 on the square root? No, you don't ever write it like this. We just know it's a square root, right? Same thing with this. We don't ever write the 10 here. You just need to know that that's a 10. Okay, so your answer here is 2. Okay, if you have, actually this one's a little bit trickier. I'll do a couple of these with you. Alright, I have log base 3 of 9 to to the x power. Are my bases the same? No. Okay. You can still solve this easily though. Because can I change that 9 into a 3 so my base is the same? Okay, and when I'm asking you to change it, we want to do it with exponents. So what is 9 the same as? 3 squared. So I actually have log base 3 of 3 squared to the x, right? Okay, let's go ahead and finish simplifying this before we go any further. Log base 3. What do I get here? Well, we don't want to change it back to 9, though. What do I do with my two exponents if I have power of a power? I multiply them, so I have 3 to the 2x. So Spencer, what's my answer to this problem? 2x. Because now I got my bases the same. They cancel. I'm left with just my exponent as 2x. So basically what I'm getting at is all these problems that have variables as exponents, if we can get them into a logarithm and match the bases, we can bring it all down out of the exponent. Hey, we won't be doing that quite yet, but that's the goal we're getting to. Let me do another one of those. Log base 5 of 125 to the x. Again, I can't mess with it right now because my bases are not the same, right? Can I make them the same? Okay, Jack, what is going to change that 125 into a 5? Okay, so I would actually have log base 5 of 5 to the third to the x, which actually just gives me 5 to the 3x, right? So Devin, my answer to this problem is my bases are the same, so they cancel. So it's 3x. Okay? Your goal is to get your bases the same. If your bases aren't the same, there's not a lot you can do unless it's a base of 10 and you can plug it in your calculator. Okay, so you want your bases to be the same. Okay. You doing all right so far? Okay, we got one more thing we want to talk about. Finding the inverse. We could not do it, but then we wouldn't know how to do our work. But then you're not making yourself better.
When are we going to use that?
Depends on what you do.
I'm going to be a bum.
You're going to be a bum? Well, you're probably not going to use much of anything then. Okay. But you're making yourself better right now. Till you get out of my classroom, we're going to make ourselves better. Okay. On example 6, we want to find the inverse of the function. Okay? So I have y equals log base 3 of x. What did we do usually to find the inverse of a function? We usually switch the x and the y, right? Now, we don't have to do that here because up here, didn't we already figure out that these two things are inverses of each other? So if I have this general form, I should be able to change it into this, shouldn't I? So instead of wasting our time switching our x and our y, I know that the inverse is going to be what? 3 to the Yeah, sorry. Well, actually, we got to switch them first. My fault. We got to switch our x and our y's and then go after that. So we do have to switch them, but once you switch them, and then it's 3 to the x power equals y. Sorry to confuse you. Switch your x and your y, and then go ahead and take your route. Okay? So let's do one more of those since I confused you guys. Y equals log of, we'll just go x here. Now I skipped out on one thing. What did I leave out? The 10. Okay, I just want to make sure everybody knows that's the 10. Switch your x and your y, so you have x equals log of y. So your answer is 10 to the x equals y. Okay. So finding the inverse, you're actually reflecting it over the line y equals x. You guys remember the line y equals x, the diagonal line? Okay. When you reflect over that line, I think I have a graph here. Okay, so let's say I take this point. Okay, here's my line. I'm going to mess it up because my board's not calibrated. I didn't do too bad. Okay, right here, this is -4, 1, right? Okay, let's reflect that over this line. So I'm 1, 2, and a half. So I go my half, 1, 2. Now my point is at 1, -4. That's what I'm saying. We're reflecting it over the line y equals x when we're finding the inverse. What happened to my x and my y? They switched. Okay, so that's why even in an equation, you must still switch your x and your y's. Okay, let's do one more of these inverses. I have y equals ln of x plus 1. I think is what it says. Maybe it says -1. No, that's right. Okay. Let's worry about what we're working on right now. Okay. First step of finding an inverse, Lorelai. Switch your x and your y. So I have x equals ln of y plus 1. Now, personally, I don't necessarily like ln. I personally, while I'm finding the inverse, would probably change it to log base e. Okay, you don't have to. If you know that's log base e, go for it. Because now I'm asking myself what? E to the equals y plus 1. Now, when I'm finding an inverse, I need to make sure to solve it for what? I got to solve it for y. So now I need to do what? Subtract your 1. So you actually have e to the x minus 1 equals y. Okay. Again, if you don't want to change that to log base e, you don't have to. I personally like to. It's just personal preference there. Just make sure you understand that ln is log base e. Okay. Questions on that? Again, that's kind of just the introductory part here. Don't forget about this. This is probably one of the most important bases for all of logarithms. Right here. If you can get your bases to be the same, they cancel out. Okay, that's a good thing. We're going to get to where we have to transform things into same bases so we can get them to cancel. Alright, and then the last thing in this section is graphing. How do you graph an exponential function? You make an xy chart, pick your x's, solve for your y, right? Okay, I'm not going to, there is a special equation for logarithms and graphing and what happens to the graph and stuff like that. It's in the green box at the top of page 489. If you want to learn it, go for it. But if you make an XY chart and you plug in your numbers, you're going to figure it out. Okay, so that's up to you how you want to do it. I'm not going to have you memorize a whole nother form. Okay? Sure thing. All right. This day's Wednesday, right? Okay, this assignment is going to look pretty long. I know there's some of you gone for track tomorrow. We will add on to this tomorrow. And actually probably on Friday also. So we're going to give this 3 days to make sure we have it done good. So, track people gone tomorrow. If you don't want to work on algebra while you're gone, that's fine. Okay, there's a whole bunch of problems here. Okay, so get started on those. Some of them aren't going to take you very long though. But if you're not going to do anything for track tomorrow, understand that you'll have stuff to make up on Friday. But we'll still be doing the same type of thing. But I'll give you more problems each day.